Are you aware that still in physics, that the position of an object in a Cartesian coordinate can be what? Can be described as this. Can be described as this. P into bracket x, y. Okay? Where this x is known as the what? Horizontal component. Horizontal component. Horizontal component. Component. Okay? And your y is the what? Vertical component. Vertical component. So the position of an object in a Cartesian coordinate. Cartesian coordinates. The position of an object in a Cartesian coordinate can be described as this, P, okay, into bracket x and y, where x is the horizontal component and y is the vertical component. Take this diagram for example, and for you to obtain, quickly take note, for you to obtain the distance between 2 points in relation to this, okay, we are going to use we're going to get the distance from geometry using Pythagoras theorem. From geometry using what? Pythagoras theorem. So let's say you have something like this. Look at this now. You have something like this. Okay. This will represent your what? Your y. And this is your x. And then you have something like this. Okay. So here, take notes. Why this place is your point A? Here is your point A. This part here is your point B. Automatically, this is your point C. Are you with me? Therefore, there is a relationship. So you have from this point to this point. That's your y what? Y2. And this point is your what? Y1. Okay? I'd like you to understand. So what that means is that you have here, around there, you have x2, y2. Around there, you have x1, y1. Just follow me. So why did I say you have x1, y1? This side is your y1. And this point here is your what? This point here is your what? X1. Why this side here gives you your y1? Okay? Are you with me? Sorry, this point here gives you your x2. Why this point here? This point here gives you your what? X1. Okay, sorry. X2, X1. Y2, Y1. Okay, are you with me? So in this case here, what you have is that to get the value here, it will be X2 minus what? X1. And then around this place, what you have will be your what? From here, it will be Y2 minus Y1. Okay, so you have this. Are you with me now? So let's say you have this now, and then they ask you to calculate the distance. According to the Pythagoras theorem in geometry, you have from here to this place is what? AB, okay, square will be equals to what? AC square plus what? Plus your what? What do you have? What's this? BC plus BC square. Are you with me? So according to Pythagoras theorem, you are going to have this. And if you get this, the implication is that for you to get a distance between from point A to point B, it will now be what? A, B square will be equals to, what do you have in AC square? To be x2 minus x1, all in bracket, square. And what do you have in BC? Which is y2 minus y1, it will be plus bracket y2 minus y1, all in square. And then to make this A stand on its own, it will now be AB. What do? You have to square root both sides, okay? Square root both sides, okay? And then you square root. You have x2 minus x1 bracket, okay? Are you with me? Square plus bracket y2 minus y1 all square in the square root. So these two will cancel this square root. Therefore, to get the distance, according to Pythagoras, from Pythagoras, you now have AB will now be equal to the square root of x2 minus x1 raised to power what? 2. Okay? Plus bracket y2 minus y1 raised to the power of 2. With this formula, you can be able to determine the position of an object. Okay, now this leads us to what we call concept of position. Okay, this is what we call the concept of position. Concept of position. Now, why in my video while I was talking, I mentioned distance. Okay, I mentioned distance, and also one way or the other, there's no way you talk about distance, you won't relate it with displacement. Okay, so I want you to know that distance is a scalar quantity. Scalar quantity. Okay, follow me. Why displacement? Displacement is a what? Is a what? A vector quantity. This one only have what? Magnitude, but no direction. But displacement has what? Magnitude and direction. Let's put it this way so that you can understand. Take distance as movement. Take distance as movement. But take displacement as locomotion. Locomotion. What does that mean? A movement in a specified direction. But this is just a movement. I can move my hand, move this. But when I move my hand towards the center, either to take food. So I'm just trying to create that for you to understand the difference between displacement and that. I'd like you to subscribe to my YouTube channel, and I'd like you to follow me on Facebook at Adobe Fikemba. And I will see you in the next video to apply this principle in an example that we will solve together. Thank you.